In this presentation, we're going to revise differentiation. So this differentiation is not part of the course that this presentation is intended for, but it is required because what will be included in this course will include things like partial differentiation, and so because of that, you need to just revise differentiation. Also, differentiation comes into things like integration by parts, so it's good to have a bit of revision on differentiation ready. So what I'm going to do here is just a remark that the first question is, I'm going to do 9 questions, and the first question is x squared, f of x equals x squared. Now just a remark, there's an alternative notation, and y equals x squared is how we might also formulate this, and we would write the derivative of, in terms of y, as dy over dx. Okay, and in this case I wrote out the answer there, it is 2x. Now, I'm going to sort of look at the main problem here, question 1, and remark that what we are dealing with here is x to the power of some number. Okay, so the number we're dealing with here is 2. And so we're going to sort of say n is equal to 2. Okay, now the derivative of n is equal to 2, or when n is equal, so n is equal to 2 there. So this comes into play here, this n is 2. So what we do when we get the derivative of f of x, and we just sort of like put a dash up here as the superscript. Okay, we put this little dash up here just to say this is the derivative of f of x. The derivative has the form n times x to the power of n minus 1. Okay, and in this case what we're going to do is multiply by 2 times x and 2 minus 1. 2 minus 1 is simply 1. Okay, so 2 times x to the power of 1. And anything to the power of 1 is just itself. So the answer is actually 2x. Okay, straightforward enough so far. Okay, so what we're going to do is go on to the next one here, question 2. Okay, and I just wrote it out there partially. I just sort of was completing it there. So the full question is, what we have to do is get the derivative of this. Okay, so it's 2x, which is a term in terms of x, or an expression in terms of x, but we also have a constant term here. Okay, so the derivative of a constant term is always 0. Okay, so essentially we're just going to ignore that part and concentrate on this part only. Okay, so what we're going to do here is write out f of x, and that is 2 times x to the power of 1. So in this case, n is going to equal 1. N minus 1 is going to equal 0. Okay, so that goes down here. That power there, that power term. My arrow is not particularly pointy. I'll just make my arrow a little bit more pointier. This constant term here, we can just sort of separate it out at the front. Okay. So what we're going to do here is state that it is 2 times, and then we actually look at the main derivative 1, because n is 1, times x times n minus 1. Now we can ignore the 1 from now on. X to the power of 1 minus 1 is x to the power of 0, and that is simply 1. 2 times 1. Anything to the power of 0 is always 1, and that means that the overall answer there is 2. Okay. So that's the first 2 that done, and what I'm going to do now is this next one here. This is going to be very short and sweet. This is question 3, and f of x in this case is 1/2 of x squared. So if you recall question 1, okay, where we had a look at x squared, and we found that the derivative in that case was 2x. What we're going to do here is something similar. Essentially what we're going to do here for our question 3, our derivative is 1/2 of 2x, okay, because f of x, or the x squared, the derivative of x squared is simply 2x, as we sort of seen earlier, but because we have this 1/2 here, we have to also include it down here. So we have 1/2 times 2x, that simply gives us x. Okay, so that was a short one. So next one is question 4. And question 4 is a long expression, but a lot of very simple components to it. So 2x squared, okay, plus 4x plus 4, okay. Now, just as a remark, the derivative of this this and this separately is we just combine them together to get the overall derivative. So the derivative of 2x squared, again, is just like we've done with question 4, is 2 times 2x, okay, plus 4 times x to the power of 0 is 4 times 1, okay. So that follows on from question 1 and question 2 respectively. So if you're unsure where I got those, that's question 1, question 2, and the constant term is 0 there, so plus 0. So our derivative is equal to 4x plus 4. Okay, that's the overall answer there, 4x plus 4. Okay. Essentially, again, all you have to do is just add up all the component terms for each of the 3 parts. Now, this next one is question 5. It's going to be a little bit trickier. Okay, the square root of x plus 2. Actually, this is question 5, and this is our function here. F of x is the square root of x plus 2. Essentially, what you can do here is this follows on from something called the chain rule, but we actually don't need to get into the chain rule yet. Okay, just to sort of say, actually, do you know what? I will use the chain rule just to make it as explicit as possible. Okay, so what I'm going to do first off is get the derivative of the inside part, which is x plus 2, okay, and then get the derivative of the outside part there, okay. So essentially what we're doing here is the derivative of x plus 2 with respect to x, okay, and what we're going to do is get the derivative of the square root of x plus 2 with respect to x plus 2, okay. So we just multiply those two out. Now it's a little bit complicated. The chain rule takes a while to get the hang of, but just to sort of remark, this is the inside part, and this is the outside part. Okay. Now the derivative of dx plus 2 over dx is simply 1. Okay. And the outside part is derivative of square root of x plus 2. Okay. What I'm going to do is slightly rewrite that as x to the power of a half, okay? But essentially what we're going to do here is just treat this as if it was x. And that's the long and short of it. So what we're going to do is just treat that if it was x. So here, n is going to be equal to 1/2. Okay, the square root is also something to the power of 1/2. N minus 1 is equal to minus a half, okay? So what we're going to do here is 1 times the derivative of that. It's x plus 2 times 1/2 to the power of minus 1/2. That is the overall answer. Okay. And so we can rearrange our formula here. Anything to the power of minus a half is 1 over the square root of x plus 2. Okay, that's x plus 2 to the power of minus a half. But we're also going to bring in that 1/2 term there. So we just multiply it by a half. Now the 1 times that, essentially we just can ignore the 1 altogether. Okay. Now, essentially that's the long way of doing it, and this is using the chain rule. Okay. But what you could have just done there is, rather than looking at it in terms of x, just look at it in terms of x plus 2. Okay, using the chain rule, the logic of it becomes very, very clear. But if you want to take a shortcut and sort of say, oh, just get the derivative with respect to x plus 2, that's also would work. Okay, but then first you should know the proper way of doing it, and then later on you should know the allowable shortcut. Okay, so that was a very tough one this time, and it requires the chain rule, which is, I actually didn't realize that was there. I didn't actually write this sheet. So f of x equals 1 to the power 1 over x. Now here, x is equal to, or sorry, I'm going to x 1 over x is equal to x to the power of minus 1. Okay, so here n is equal to minus 1. Okay, and n minus 1 is going to be minus 1 minus 1, which is equal to minus 2. Okay, so what we have here is this: the f of x is n, so that's minus 1, times x to the power of n minus 1, which is minus 2. Okay, so x to the power of minus 2 is equal to 1 over x squared. Okay, so essentially what we end up is minus 1 over x squared. That is the full answer there. Okay, so I'm going to do a few more of these. I'm just going to get them all out of the way. This is question 1 to 9, so there's a few left now. So this is question 7 off the sheet. So what we're going to do here is get the derivative of 3 over x plus 1. F of x equals 3 over x plus 1. Okay, now what I'm going to do here is treat x plus 1 as x. Okay, now this follows from the chain rule as x. Okay, so essentially what we have here is f of x can be written as 3 times x plus 1 to the power of minus 1. Okay, and the derivative therefore is, here what we're going to do is let, again, something similar, n is equal to minus 1. Okay, so what we have here is 3 times minus 1 times x plus 1 to the minus 2. Okay, because n minus 1 is minus 2. Okay, again, it's following from question 6. When I rearrange that, 3 and, well, first off, I'll actually look at this part here. That becomes 1, that there specifically is 1 over x plus 1 squared. Okay, and when I bring in the 3 and minus 1, that becomes minus 3. Okay, so that's the full answer there. Okay, minus 3 over x plus 1 all to be squared. Okay, so that's the full answer there. Now, again, this is following from the chain rule. Now, this is sort of, when you get good at these, treating x plus 1 as x, that takes a bit of practice and to know when that's right. Okay, so before you sort of really try that on your own, I suggest you look at the chain rule properly, so you have like properly the idea set out in your head. So don't really get into those yet until you really have a good strong notion of the chain rule. So question 8 is, we're nearly there. Question 8 is as follows. Something very similar. F of x equals 1 over the square root of x plus 1. Okay, and again, treat x plus 1 as if it was x. So what we would sort of say here is f of x is equal to x plus 1 to the power of x plus 1 to the power of minus 1/2. Okay, here n is equal to minus 1/2. So n minus 1 is minus 3 over 2. Be very careful with those ones, okay? So minus 3 over 2, okay? Also, so that's pretty much we use the same sort of idea then. So essentially what we're going to do is have the derivative is n, so that's minus 1/2, times x, or in this case x plus 1, the power of n minus 1, so minus 3 over 2. Okay. What we can do is rearrange that. Okay. So for example, x plus 1 to the power of minus 3 over 2 is equal to, I'm just going to write that there, so that's the minus 1/2 there. And this is 1 over x plus 1 to the power of 3 over 2. Okay. Now, really, there's nothing much you can do with that 3 over 2 in this instance. So essentially what you can do there is sort of simplify the expression. I'm just going to make a bit more room for myself here. Simplify the expression and sort of say that is equal to minus 1 over 2 times x plus 1 to the power of 3 over 2. So finally, last lap, we're going to do question 9 of the question sheet. And question 9 is equal to x over x plus 2. Okay, now this one is sort of long-winded, and really what the correct approach here is using the sorry, I'm just going to bring that back in a shot there. What we're going to use here is the quotient rule. So this is the a little bit about the this probably actually got brought in a little bit early. Anyway, we're going to be doing the quotient rule soon enough. So we're going to write this in the form u over v. Okay, f of x. f of x it has a numerator, which we're going to call u, and then denominator. And so f of x, derivative of x is v times du dx. Okay, and again, it's handy to use both types of notation. Minus u dv dx. Okay, all over v squared. Okay, now actually, sorry, I should check that in my head. What you might do is take a moment to sort of check that I got that formula right. I'm going to do that. Yeah. Anyway, so we're going to derivative of x is 1. Okay, so what we have here is x plus 2 times derivative du dx is derivative of x with respect to x. That's 1. Minus x, that's u. Derivative of dv, derivative of x plus 2, that is 1. Okay. And over x plus 2 squared. Now, so what we have here is x plus 2 minus x over x plus 2 to be squared. And that works out to be 2 over x plus 2 squared. Okay, so that is question 1 to 9 of the differentiation review. Okay.